Okay, let's continue with the trigonometry unit. So we've been mostly involved with right triangles, but we want to take it further. So let's talk about the area of a triangle. And so you've learned until 2 classes ago, actually, the only way you could find right angles if you knew the base and the height. So you've worked with like right triangles. So here's example one. Let's say here's a triangle and it was a right triangle. And let's say the base, the height, let's say this height is 7 and the base is 10. And let's say you leave the units off. And so to find the area, it's 1/2 the base times the height. And so it's 35, like units square units. So if if it was like centimeters, then the answer would be 35 square centimeters. Now, another example, maybe you didn't have, maybe you had some regular triangle, maybe you had a regular triangle or something like that, but you were told, the base is, let's say this is, 12, and you were given the height, the altitude was, 5. And you say, okay, I can still find the area of this triangle because I know the height. So you say, fine, 1/2 the base times the height, and this is 30. So let's pick a unit. How about inches? And so it's inches squared. That's fine. Now the problem is, and so the question is, do we have to, what if we don't have a right triangle? What if we don't know the altitude? Well, we kind of explored this a little bit. We do know that if we have an equilateral triangle in the last class, we actually figured out a way to figure that out. But if you think about it, we actually dropped an altitude here. Remember, so we knew this was a 30, 60, 90 triangle. If we said this was S over 2, and this was S radical 3 over 2. And so technically, this is how we found, so it's 1/2 the base times height, and we knew the answer was S squared radical 3 over 4. So right triangles, if you're given an altitude, equilateral triangles, we're able to find the area. But what if I don't have an equilateral triangle? What if I have, something like this? How about we have this triangle, and I'm telling you that this side is 5, this side is 11, and this is 68 degrees. How do I find the area of that triangle? My computer's a little crooked. Sorry about that. How do I find the area of that triangle at? Where do I even begin? Does it have first of all, does it have an area? And you say, yes, it has an area. You can put a big rectangle around it. So we know it has an area. We know there's space inside. The question is, can we find the area? And the answer is yes. So let's take a diagram. So the idea is, given 2 sides and the included angle, we can find the area. Once again, we have 2 sides and the included angle. We can find the area. So let's derive the formula. I'm not going to ask you to derive it, but so let's take this triangle. This is any triangle. Okay. And we're going to call this side A. Let's call this side B. Let's call the base A. And we're going to call the included angle C. So in the same way that I gave you 5, 11, and 68 between, we have a B, an A, and angle C. Well, like over here, let's put an altitude in. Let's put an altitude in here. And let's call that h. So that's the altitude, the height of our triangle. Right? So let's see. So you're looking at this and you say, Mr. Adler, we have a right triangle here. And if I'm standing at angle C, I have the opposite and the hypotenuse. That's sine. So sine of C is equal to h over b. And if I want to solve for the height, how do I undo division? I multiply both sides by b. So multiply both sides by b, and we get h equals b sine c. And we're ready to make our formula. Well, the formula of a triangle, it doesn't matter what kind of triangle it is. We know that the area of any triangle is 1/2 the base times the height. And this is our formula for the area of any triangle, given two sides and the included angle. If it's any other thing, it might not work. So let's do some examples. Let's get some examples going. Oh, these erasers are killing me. Sorry. So, well, let's take a look at our example up there. Do we have two sides and an included angle? Well, the answer is yes. So the area is 1/2 the base times the height, sine of 68. Go to your calculator. Did I write the answer down? Nope. Let's see. So you go to your calculator. Let's turn it on. Go to your calculator. Turn it sideways if you have to. Let's see. So you do 68 sine times 55. Enter. Divided by 2. Let's see. 25.5 units squared. Let's try another example. How about a triangle 6 and 11, and the included angle is 70 degrees. Can I quickly find the area of this? Yeah. Let's see. We know that the area is simply 1/2 A, B, sine, C. That's it. You put it in your calculator, you should get the answer of 31. And I'm obviously thinking, I'm being really bad. So let's call this centimeters. This is 31 centimeters squared. Let's try another one. And simply try this on your own. How about 7, 8, and actually, let's do something a little different. How about we do something within a obtuse angle? Let's see, 3, 9, 100 degrees. Because we never asked you that. We asked you acutes. So let's think about that. We've done acutes, right triangles. Now we're doing within an obtuse angle. Same thing. We have two sides and an included angle. 1/2 AB sine C. This might be the base. This is not the height. We're totally fine with that. This takes care of that. Now, final answer. Let's see. Let's go to our calculator. Let's see what the answer is. Go sideways. 100. The sine of 100 times 27 divided by 2. 13.3. So you say, well, will it work on a right triangle? Yeah, a couple of things. What you'll notice is that you will notice a couple of things. There's a couple of things I want to say before I finish. First of all, if you just type in the sine of 90 in your calculator, it's going to give you 1. And hence, if you have a right triangle, this is AB, and this is 90 degrees, 1/2 AB sine of 90 is equal to 1/2 the base times the height. That's why this works. Another thing I want to say, what else do I want to talk about? Why does this work? Well, it works because of, if you recall from your geometry class, when we were trying to prove triangles congruent, one of the ways was side angle side. There's all because of side angle side. There's no other triangle that I can draw, a 6, 70, 11, that looks different from this. Whatever the third side is, it's unique. So this triangle, let's see, a 6, 70, 11 triangle, this is unique. This is unique. There's no other triangle. Am I going to ask you this stuff in class? No. But you don't have to worry about are there other answers. Another thing I don't want to talk about in this class, or maybe I'll talk about a little later, is this question. Here's a triangle, and the sides are 5 and 9, and I'm telling you that the area is 15, meters squared. Find C. And so you might say to Mr. Adler, no big deal. No big deal. I know the formula, so it's 1/2, 5 times 9. Sine of C equals 15. And some of you are saying, once again, Mr. Adler, it's no big deal here. Just isolate the sine C. So multiply both sides by 2. So we have 45 sine C equals 30. And then you solve for sine of C. Sine of C equals 30 over 45, which is 2/3. And you say, hey, Mr. Adler, no big deal. Well, the fact is, it actually is a big deal. And this is really advanced for this class, very advanced for this class. What I want you to do, if you're interested, I want you to solve that equation the way that we solve the other answers. You'd say C equals sine inverse of 2/3, and you're going to get an answer. What is the answer? Let's go to my calculator, and we're going to do 2 divided by 3. Oh, clear it. 2 divided by 3. 2 divided by 3. Enter, and I'm going to do the inverse sine. I get an answer of 41.8. And so you say, okay, that's the answer, Mr. Ed. Like, what's the problem? What is my problem? And I would say to you, I would ask you, what is the sine of 140 minus 41.8? Put that in your calculator, and you're going to discover that also equals 2/3. In an advanced math class, we'll be exploring the identity that the sine of 180 minus x is equal to the sine of x. I'm not asking you this here at all, but it's something to think about. And that's it. So work on the homework.